In this video, we're going to look at examples that involve implicit differentiation. Example number 1. Find dy dx for y squared equals x squared plus sine of xy. Before I get started, I want to think a moment about what's going on here. Think about what rules I might need to work out this problem. First, I see the y squared. Here, I will need a chain rule because remember, when I'm finding the derivative of y with respect to x, y is a function. Therefore, y squared will need a chain rule. In addition, I see sine of xy. It will need a chain rule. And then inside, we'll need a product rule because of that xy. All right, let's get started. Dy dx, let's find this derivative. The derivative of y squared is 2y dy dx. Remember, because of that chain rule, y is a function, so we do have to multiply by its derivative. That y is like our inside function. Equals x squared. Well, its derivative will be 2x. And then derivative of sine of xy, we have a chain situation going on here. So derivative of the sine of something is the cosine of that function, that same thing, cosine of xy, times, now I need to multiply times the derivative of xy, which will take a product rule. So I'll think of x and y as my u and v. So it'll be x times the derivative of y, which remember the derivative of y is dy dx, plus derivative of x is a 1 times y. So here's my first step. I have found the derivative of each piece. Now I want to rearrange and simplify and solve for dy dx. So I see a dy dx here, and I see another one hidden over here. But notice this piece is multiplied in by cosine of xy. So I'm going to distribute first before I move everything to one side. So 2y dy dx equals 2x. And now I'll do that distributing. This is cosine plus cosine of xy times x dy dx plus cosine of xy times just that y. So now I'm going to look for the pieces that have a dy dx. That's here, and I see another one here. And I'm going to get all those terms on one side and everything else on the other. So 2y dy dx, we'll leave that alone. We'll subtract and move that other term over. So cosine of xy, x dy dx. And then on the other side, I'll have 2x plus cosine of xy times the y. All right, now I can factor out my dy dx on this left-hand side. So dy dx, and I'm left with 2y minus, and I'm just going to make a little change here to make it look a little bit better. I'm going to take this x and put it in the front just so it looks a little bit nicer. So x cosine of xy. And this equals 2x plus, and I'm going to do the same thing over here. I'm going to move that y to the front so it just looks a little bit better. All right, now that I have that factored out, I can divide both sides by this 2y minus x cosine xy. And remember, I'm doing this so that I can get dy dx by itself. So 2y minus x cosine of xy. And these now cancel. And I have finally that dy dx is 2x plus y cosine of xy over 2y minus x cosine of xy. There we go. There is our dy dx. All right, let's move to another example. Let's find dy dx for x cubed plus y cubed equals 18xy. Again, I'm going to think about what I'll need to do before I get started. Seeing this y cubed, I will need a chain rule here because remember y is a function. So y is the inside and the function cubed, the cubed is part of the outside function. And then over here, I see that I'll need a product rule for the 18xy. And I'll think of it maybe as 18x times y when I do my product rule. All right, so now we can get started now that I've thought about what's coming for us. All right, so x cubed's derivative is 3x squared plus the derivative of y cubed. Remember, y is a function, so I have to treat it as one. So 3y squared times dy dx. Remember that extra little bit when we're doing this implicit differentiation. Equals, and now I'll do the product rule here. So I'll leave 18x alone. The derivative of y, well, is the derivative of y, so dy dx. Plus, and now the derivative of 18x is just 18 times the y. We just leave it alone. All right, now it's time to find all my dy dx's. See one here and one here, and collect them on the same side and put everything else on the other side. So I'm going to have 3y squared dy dx minus an 18x dy dx equals, that 18y is still there, but I need to move that 3x squared over. So I've moved all of my terms that have a dy dx to the left. All of my terms that do not have a dy dx, they are on the right-hand side. That allows me now to factor out that dy dx. So I'll be left with 3y squared minus 18x, and that equals 18y minus 3x squared. And now I can divide by 3y squared minus 18x on both sides. And these cancel, and I get that dy dx is 18y minus 3x squared over 3y squared minus 18x. And that's a fine answer, but I do notice that each coefficient in the entire thing is divisible by 3. So I could go through and say this is 6y minus x squared over y squared minus 6x. And that is just a little bit of a simplification because everything was divisible by 3. I could divide everything out. This one was okay too. Both are okay, but that second one is just a little bit nicer. All right. Our next example, the square root of xy equals x cubed minus 2x. And again, we are looking for dy dx. So what am I going to have to do in this problem? Here, that square root of xy, that is going to be a chain with a product inside. And then the other side doesn't look too bad. X cubed minus 2x, that's going to be okay. I am going to take one note though, one moment. Xy to the half equals x cubed minus 2x. That slight rewriting helps us see that chain rule a little bit better. All right, so let's take our derivative. We'll have 1/2 times xy to the negative 1/2 power. And now I need to multiply times the derivative of that inside. So that's the derivative of xy. This is where we're going to need that product rule. So I can see my x and my y are my two pieces. So we'll leave x alone times the derivative of y plus x's derivative, which is 1 times y. So there's that piece. So I have done the chain rule, and then the product rule was inside. So now I'm done with that part. And the other side, the derivative of x cubed is 3x squared. And then derivative of minus 2x is just minus 2. Okay, so now I need to get that dy dx by itself. So I see it right here. So my first step, I think I'm going to divide all by 1/2 xy to the negative half. And that lets these cancel. So what am I left with? X dy dx plus y equals 3x squared minus 2 over 1/2 xy to the negative half. And then what else can I do? On this right-hand side, I'm going to clean that up just a tad before I go too much further. Notice that this is the same thing as 3x squared minus 2. Now, dividing by a half, I'm going to move that half up, is the same thing as multiplying by 2. And then an xy on the bottom to the negative a half power is really just an xy on the top to the positive a half power. So now what I'm going to do is I'm going to look at this piece over here on the far left and this slightly more simplified piece. It's going to make it just a little bit easier to clean up. Rather than dealing with this, I'm just going to go ahead and move that up and get it out of the way, that negative exponent. So now what do I need to do? I need to subtract that y from both sides. So I have that x dy dx is equal to 2 times 3x squared minus 2 times xy to the half. And again, I'm using that more cleaned up version. And then I subtract y. Again, I want to get dy dx by itself, so I'll just divide both sides by x. And those cancel, and I have dy dx equals 2 times 3x squared minus 2 times xy to the half minus y all over x. There we go. There is dy dx. All right, let's move to the next one. We want to find dy dx for x equals the cotangent of y. So as I'm looking at this, I am going to need a chain rule here for cotangent of y, because remember it's cotangent of a function, not just cotangent of a plain old variable. So I will need the chain rule there. All right, so the derivative of x is just 1. The derivative of the cotangent of something, so the cotangent's derivative is negative cosecant squared of y, and then the chain rule says I need to multiply by dy dx. All right, there's my only dy dx, so I'm just going to divide through by negative cosecant squared y, negative cosecant squared y, and I have these cancel, and it looks like dy dx is 1 over the negative cosecant squared of y, which that can be cleaned up. I know my reciprocal identities for all of my trigonometric functions. So a cosecant on the bottom is really just a sine on the top. So dy dx is negative sine squared of y. So there is a little bit more simplified. Okay, let's go to our next example. All right, this one is asking something for a little bit different. It says find the equation of the line that is tangent to the curve at the given point. So if we want the equation of the line, so equation, we're going to need a slope and a point. Well, we've got our point. They gave it to us. It's negative 2, 1. We're good there. But now we need to find our slope. And to get the slope, we will need the derivative. And because we do see that this one is not written explicitly in terms of y equals, we will use implicit differentiation to find it. So our first step is to find the derivative, and then we will write the equation of the line. So let's find our derivative. As I look along, I will need a chain rule for that y squared and for that 4y, but the rest of it should be pretty straightforward. Okay, so y squared, its derivative would be 2y dy dx, minus derivative of 2x is just a 2, minus derivative of 4y will be 4 dy dx equals, and then derivative of 1 is 0. So now I need to collect all my dy dx's together on one side and everything else on the other. So 2y dy dx minus 4 dy dx is going to equal, I'll move that negative 2 over, and it's a positive 2. Factor out the dy dx, and I get 2y minus 4. And that's still just all equal to 2. Get that dy dx by itself by dividing by 2y minus 4. And these cancel, and I have that dy dx is 2 over 2y minus 4. But I noticed that every single coefficient is divisible by 2, so I can clean up a little bit further and say that this is 1 over y minus 2. So my derivative um, in terms of x's and y's is 1 over y minus 2, but I'm going to need the slope specifically at the point I was given. Remember we were saying at 2, -1, or -2, 1. So let's figure that out. So at -2, 1, dy dx is 1 over, now I need to plug in my y, which is a 1, minus 2. So 1 over -1, so -1. So this is my slope. So we have found our slope. It is -1. We have our point, -2, 1. So we should be able to write our equation now. So as a reminder, that was our equation, or that was our equation, and our point, our slope was -1. Point slope form says y minus y1 equals m times x minus x1. And remember, this is our x1 and y1 were the point we were given, -2, 1. So we get y minus 1 equals our slope, which is -1, x minus x1, which is -2. So y minus 1 equals -x plus 2. And that's perfectly fine for me in point slope form. But you may want to clean up and move it into slope intercept. So this is point slope form. Or we can say y equals, we'll distribute that negative x minus 2, and then take that 1 and swing it around. So y equals -x minus 1 is our slope intercept form. Either of those are acceptable. Okay, so there is the equation of the tangent line. All right, let's do one more example. Let's do one more where we're finding the equation of the tangent line. So we're given this curve, 3 times x squared plus y squared squared equals 100 times x squared minus y squared, and our point is -4, 2. So what are we going to need when we do this? Here I see a chain rule, and it's going to be a chain rule on the inside as well because of that y squared, and then I'll see another y squared over there, so another chain rule. And I'm going to do one other quick thing, 100x squared minus 100y squared. I'm going to multiply that out just so that I don't have to do it later. We'll just go ahead and do that. So let's find our derivative with the chain rule for that first term. So we'll swing that 2 around. So that's going to be a 6 now times x squared plus y squared to the first power when we subtract 1. And then we need the derivative of the inside. The derivative of x squared is 2x, and then the derivative of y squared is 2y dy dx because of that chain rule. So there is the left-hand side, and this is going to equal, I'm going to use that cleaned up part. So derivative of 100x squared is 200x minus derivative of 100y squared is 200y dy dx. Okay. All right, so now we need to do some cleaning up. I see dy dx here, and notice that is multiplied into that 6x squared plus y squared, so we're going to have to deal with that in a minute. And I see one over on the right-hand side as well. So let's do some multiplying out of these terms. I'm going to take this 6 times x squared plus y squared and distribute it to each piece. So what do I get? 12x times x squared plus y squared plus 12y times x squared plus y squared dy dx. And then the other side I'm just going to leave just as it was, 200x minus 200y dy dx. And now I'm going to put all my dy dx stuff on one side and all my things that don't involve a dy dx on the other. So on the left-hand side, I'll have a 12y x squared plus y squared dy dx plus a 200y dy dx. That was from the right-hand side. I moved it over. And on the right-hand side, that 200x will stay, and then we'll bring over that 12x, x squared plus y squared that was on the left-hand side. Now I can factor dy dx out, and I'm left with 12y x squared plus y squared plus 200y equals 200x minus 12x x squared plus y squared. And I can divide 12y x squared plus y squared plus the 200y, divide 12y x squared plus y squared plus the 200y. And those will cancel. And I have that dy dx equals all of this, which I'm just going to copy and paste. And there we go. So that is our derivative in terms of x's and y's. But specifically, we need it at the point -4, 2. So let's move all this over so we have some room. So at -4, 2, that means everywhere you see an x, plug in a -4. Everywhere you see a y, plug in a 2. And if you do that and you clean it all up, you should end up with 2 11ths. So plug all those in, -4 here, -4 and a 2. Just plug in everywhere you see an x and a y, and you should end up with a slope. Remember, this is our slope of 2 11ths. Now, we're not quite done yet. Remember, we were asked to find the equation of the line. So we know our point is -4, 2. So this is our x1 and our y1. And our slope we just found to be 2 11ths. So we can use point slope form. Y minus y1 is m times x minus x1. So y minus 2 equals 2 11ths times x plus 4. This is a perfectly good answer. This is in point slope. But you also can rearrange and get it in slope intercept if you decide to do that. It'll be what? Y equals 2 11ths x plus 8 11ths. Then I'll add that 2 to both sides. So 2 11ths x plus 8 11ths plus 2, that'll be 30 11ths when you clean that up. And this would be my slope intersect form. Either of these is acceptable, just kind of depends on what you're doing. Maybe if you're asked a specific one. But those are both fine equations of that tangent line.